Okay, so today we are going to be working with writing equations for parallel and perpendicular lines. So the first thing that we need to make sure we understand is that parallel lines have the same slope. So when I'm writing an equation for a line that's parallel to another line, I need to know that the slopes are the same. So the way that I'm going to set these equations up, so it says write an equation of a line that's parallel to the line y is equal to negative 1/4 x plus 2 and passes through the point 3, negative 2. So in my information, there is given information that I need to know. So the information that I'm given is that I'm given the equation y is equal to negative 1/4 x plus 2. And the only information that I actually need out of that is the slope. And so I know that the slope of that equation is going to be the number in front of the x, which in this case is that negative 1/4. So when I write an equation for my line, I want it to be parallel. So these two lines run side by side. That's a symbol for parallel. So I want it to be parallel, which means that I want the slope to be the same. So I want the slope to be negative 1/4. And then my line as well is I want it to go through the ordered pair 3, negative 2. And so once I have the slope and a point, what I can do is I can plug it into my point slope form. The y minus y1 equals m parentheses x minus x1. So I can go y minus negative 2 is equal to negative 1/4 parentheses x minus my x coordinate, which is 3. I can distribute into my parentheses. Remember that on the left-hand side here, minus a negative is the same thing as a big plus sign or plus a positive. So I get y plus 2 is equal to negative 1/4 x minus, that's going to be plus because it's a negative 1/4 times a negative 3, plus 3/4. Then I can subtract my 2 over to the other side and get y is equal to negative 1/4 x, and this will be minus 1 1/4. There we go. And that's my equation for a line that is parallel, that goes through the ordered pair 3, negative 2. So the same thing with the second problem. Again, I'm going to write down my given information. That's important. So I want it to be write an equation that's parallel to the line y is equal to 2x plus 2. Again, the only information that matters out of there is the slope. The slope of that equation is the number in front of the x, which in this case is 2. When I'm writing the equation for my line then, I want it to be parallel to this line, so I want the slope to be the same, so the slope is going to be 2, and then it's going to go through the ordered pair 3, 2. And so when I plug this in, I go y minus y1 equals m parentheses x minus x1. So y minus my y coordinate, which is 2, is equal to my slope, which is also 2, parentheses x minus my x coordinate, which is 3. I can distribute, get y minus 2 is equal to 2x minus 6, and then add my 2 to the other side, and get y is equal to 2x minus 4. That's my equation for a line that is parallel, that goes to the point 3, 2. The next part we have is we're talking about writing equations for perpendicular lines. So perpendicular means that two lines that intersect at a 90-degree angle. And what's important for us here is the slope of perpendicular lines. We have to know that they're opposite reciprocals. Opposite meaning change the sign, different signs. And then reciprocal means it's a flipped over version of the other fraction. So with these, with 1/3, I'm just going to rewrite 1/3. And so the opposite reciprocal of 1/3, so this is positive, so I know that opposite's going to make it negative. And then flip over 1/3 and it becomes negative 3 over 1, which is the same thing as negative 3. The next one, -4. Again, any whole number I can write over top of 1, so it's -4 over 1. It's a negative number, so change the sign, it's positive, and then flip it over, so it would be 1/4 would be the opposite reciprocal of -4. 2/3, again, I'm just going to rewrite it as 2 over 3. And so the opposite reciprocal, change the sign, make it negative, and then flip it over would be -3 over 2. -3/4, again, I'm going to rewrite it first. It's a negative number, so I change the sign of it and then flip it, so it's going to be positive, and then it's going to be flipped over as 4 over 3. So when I'm doing these, I need to use perpendicular slopes. So with the first one here, I've got write the equation that is perpendicular to the line y is equal to -3/4 x plus 3, and goes through the point -4, 2. And so again, the given information is the equation. So y is equal to -3/4 x plus 3. And so the only thing that matters of that I need is my slope, which is -3/4. When I'm writing the equation for my line, again, this is the symbol for perpendicular. It's a upside down T. So I want my line to be perpendicular, which means I want my slope to be the opposite reciprocal of that number right there. So when I do this, I'm going to say that my slope, change the sign and flip it, so it's going to be positive, and it's going to be positive 4/3. And then I want my line to go through the ordered pair, -4, positive 2. So again, I can go y minus y1 is equal to m parentheses x minus x1. So y minus my y coordinate, which is 2, is equal to 4/3 parentheses x minus my x coordinate, which is -4. Again, change that sign before doing anything else to a big plus sign. Distribute, get y minus 2 is equal to 4/3 x plus, let's see, that is 16/3. Which is 5 1/3. Good. And then I can add the 2 to the other side. So I get y is equal to 4/3 x plus, and then when I add those together, 5 1/3 and 2, I get 7 1/3. With the second one, again, same thing. Flip over to the back of your notes. I think this one's on the back for you guys. My given information is the equation y is equal to 1/2 x plus 3. Again, the only thing that matters of my given information is my slope, which is 1/2. So with my line, I want it to be perpendicular, which means I want my slope to be an opposite reciprocal of the slope given. So change the sign and flip it, which would be -2. Ordered pair that I want to go through is 4, 5. So again, I go y minus y1 is equal to m parentheses x minus x1. So I go y minus my y coordinate, which is 5, is equal to my slope, which is -2, parentheses x minus my x coordinate, which is 4. I can distribute my slope, get y minus 5 is equal to -2x plus 8, and then add my 5 over to the other side. Get y is equal to -2x plus 13. And then the oops. There we go. And then the only thing we have left to do here is the bottom two problems of these notes. It's just asking whether the equations are parallel and perpendicular. We're looking at seeing if these guys are parallel, perpendicular, neither, and these are parallel, perpendicular, neither. And so to do this, to find a slope, what I can do is just get my y by itself, because I know that if I get it to y equals mx plus b, the number in front of the x is going to end up being my slope. So with these, I'm going to subtract the 3x over to the other side. Get 4y is equal to 16 minus 3x and then divide everything by 4. So I get y is equal to 4 minus 3/4 x. And so I would know that this is my slope, negative 3/4. So I can go over here to the other equation and see if it's the same thing. Subtract the 8x over to the other side, get 6y is equal to 12 minus 8x, and then divide everything by 6. So I get y is equal to 2 minus, and then just like make sure you reduce that fraction. So 8 over 6, 1 1/3, reduces down to the fraction 4/3. And so I know that this is my slope. And so what I can do is look at them. Are they the same? No. Are they perpendicular? Are they opposite reciprocals? They are reciprocals, but they're not opposite. So this is kind of a trick one. So this is going to be a neither. With the second ones here, it's kind of easy. I can divide everything by 4. Get y is equal to negative 5/4 x plus 3. And again, I know that this here, this negative 5/4 is my slope. In this problem, y is already by itself, so I know positive 4/5 is my slope. They are not the same. They are opposite signs of each other, and they're flipped over versions. So I know that these ones are perpendicular because they have opposite reciprocal slopes.